We are recording now. Thank you all for joining.
Hey.
Thank you for bearing with me on the technical difficulties there. This will get posted to YouTube later, and the meeting is also public, so people can join in from the channel, from the Cash Token Devs channel. All right, so today I just wanted to give an overview of Bitcoin Cash Metadata Registries. This is an application layer proposal for how to share authenticated information about things that are on chain, how to share that stuff between wallets. So by and large, the kind of the biggest use case here, the most immediate use case is with cash tokens, we need to be able to associate a name and a ticker symbol and an icon with and some other data with token category IDs, those 32-byte identifiers that identify token categories. And so if anybody is following along with some of the cash token stuff, oh, here we are. We'll admit some more. Cash token devs, let's join here. Okay, excellent. We've got 13 people on. Right, sorry about that. Right, so Bitcoin Cash Metadata Registries are JSON files that can be broadcasted either over HTTPS or on-chain. They can be resolved by wallets either using a trusted URL or and then later upgraded to on-chain identities, and then on-chain identities can sign the latest state of registry. So you can broadcast registry updates with on-chain transactions. Should we chat about cash tokens at all? Do people have a sense for? Maybe I should give a quick overview of the cash token stuff.
Yeah, I'd appreciate that, especially just the parts that.
Yeah.
Could you actually limit it to what's the interaction? So is it required? Is it necessary? Is there some parts of this that are unrelated?
Yeah. Well, this is an application layer thing only. It's not. None of this is required by any of the protocol consensus stuff. This is how we deal with names and icons in wallets, and do it so that users can't be defrauded by having somebody create a fake token that is, JSON dollars. It's 100% backed by the integrity of JSON, but it can be issued by Chris, right? So, being able to, the fact that anyone can issue tokens in the Bitcoin Cash system means that it's important that we are able to authenticate metadata about tokens, so that naive users are not tricked into accepting something that is impersonating an asset they know. And that happens all the time on other cryptocurrencies, and has happened in the SLP space. In fact, some of the earliest registered SLP tokens were US dollars and euros and renminbi and stuff like that. So being able to authenticate metadata about tokens is very important for avoiding scams and impersonations and things like that. So the only interaction here that is useful to know how cash tokens works is in general, all tokens in Bitcoin Cash tokens, all tokens have a 32-byte identifier called their category, and that identifier actually comes from the transaction ID that is responsible for creating those tokens, or creating the category that the tokens are part of. So that's all. The only technical thing that is useful to know when we talk about Bitcoin Cash Metadata Registries is that every token in the Bitcoin Cash system has a 32-byte identifier that is actually a transaction ID. But from that transaction ID, the whole history of all of the tokens are derivable if you're scanning the chain. So we'll start from there. I'll go ahead and just jump right into. Well, I have this out actually while we're talking about cash token creation. I have a graphic here that maybe will help to illuminate stuff a little bit. Here on the left, you see there are two transactions. There's one has an ID that's green here, starts with A1, and below there's an ID that's purple and starts with B2. the way that creating cash tokens works is if you have the 0th output, if you have the very first output of a transaction, you can create tokens that are part of the category that is defined by that transaction ID. And so when we're talking about categories being transaction IDs, this green transaction ID is controlled by the 0th output of that transaction. So you can create tokens with this identifier. But that is it. So that is how cash tokens works. The output 0 is critical for deciding who gets to issue tokens with that transaction ID. And then from there, we can switch over to Bitcoin Cash Metadata Registries chip. I'm going to give you kind of an overview straight from the document. So some of the stuff we can talk about, the benefits here. Yeah, we'll do a high-level overview. So some of the benefits here are that the JSON schema itself is very extensible. So it's actually a very bare bones schema. There's only a few properties that are part of the standardized spec, and we'll do some examples in a moment. But then the spec itself has an extensions field where individual wallets and groups of wallets and various vendors and service providers can start to work on standardizing things that they want to put in registries, but we don't have a standard field for, and doesn't need to be part of the specification. There can be informal vendor specific fields that you add. And in the spec, I can actually scroll down to show you that the extensibility. There's a section called extensions, which gives you a sense for there's an extensions field, and you can put whatever you like in here. So if I create a contact extension and I try to get a few other wallets to support adding contact information for identities, that could be one possible way to do it. There are also 2 extensions that are part of the spec. One for localization, for internationalization, for being able to translate metadata, and then one for a technical thing we'll talk about. So I'm going to scroll back to the top and just kind of go over some of the benefits. Another piece of the standard is it actually lets us define a generalized strategy for interpreting what is inside non-fungible tokens on Bitcoin Cash. So non-fungible tokens in the cash tokens system, they can be up to 40 bytes of whatever you like, and decentralized contract systems can use that to manage information like how many tokens. How many satoshis I pledged to an insurance contract, for example, or the decentralized exchange demo I posted a few months ago uses that for uses commitments to pass information about how many tokens a user contributed to a buy order or a sell order, and keeping track of the amount of satoshis they contributed, etc. So there's a bunch of things. Commitments are an important piece of the cash token stuff. If you're not familiar with that, I encourage you to go take a look at that, the cash token spec, and get familiar with that for those following along on the call later. But part of the metadata registry spec is being able to define what is inside those commitments so that wallets can actually understand it deeply. So we can actually, if a wallet understands the NFT parsing part of the registries, metadata registries, the wallet can actually create a table of the user's open orders on a decentralized exchange, and it can actually know that these bytes represent numbers, and they represent the total tokens for sale. These bytes represent a number, and it represents a number of satoshis, and it can be summed across NFTs. And so we can create a total BCH order value. So what's quite cool is actually with the metadata registries, we can you can specify at a very high level how the whole API of a decentralized application works, how its commitment API works, and wallets can actually, in a very generalized way, be able to understand that and represent that data for users. So you actually don't need to have custom software running in your wallet to be able to at least understand, hey, this is a receipt for a flip starter where I pledged this amount, or this is a buy order and this was the amount, here's the number of tokens or whatever. Your wallet can actually, with the metadata registries alone, your wallet can at least decode those tokens and display them for the user.
Hey, Jason.
Yes.
Could I beg you to Eli Python developer, like
yes,
go up to a higher level if you could, and
yeah.
help me understand, like, what's a use case, like a specific story where this is useful. Like,
Yes.
is this meaningful at a user level, or is this meaning at a application development level, or
Thank you.
like what's a story where this all fits in? Because I mean, I have read the whole thing and I think I basically understand it, but yeah.
Yeah, so for a decentralized application that is like a crowdfunding application, if we give the example of Flipstarter, we can build Flipstarter as a covenant that when you make a pledge, you give the covenant the money. And if we want you to be able to get your money back, if you want to be able to cancel your pledge, or if the pledge fails, if the campaign fails, then a very efficient strategy for designing that decentralized application is actually having the application issue you a non-fungible token as a receipt for your pledge. So when you pledge, the application gives you an NFT that says how much you pledged. It keeps your money and it gives you that NFT. And now you have an NFT. Without the metadata registries, most wallets would have to have custom code that specifically understands how this Flipstarter contract works, so that the wallet is able to even recognize what it's looking at. Like, it's got an NFT with some bytes. It can figure out what the category is, but now it has no other information. It doesn't even know like what the name of the application is. But with the metadata registries, we can actually define, it's a pretty simple JSON schema to give that application a name in the wallet and give it an icon and have a web address and stuff, but also to put the token information, so we can have the category, and so it can identify, hey, this token was issued by the Flipstarter contract. And then further, there's actually an NFT kind of parsing strategy built into this stuff, where we can define in the metadata registry how the wallet should read the commitment field. And the way we actually define that, we use the same virtual machine that is used by the contracts themselves. So in a cool way, the wallets can, if the wallets integrate a Bitcoin Cash virtual machine implementation, there's lots of languages. You can do the one from any of the nodes, or there are a number of JavaScript ones. Your wallet can actually use the Bitcoin Cash virtual machine to parse the contents of the NFT in the same way that it's actually parsed on chain, and then read fields from that NFT. So your wallet can actually, without the developer of your wallet necessarily knowing anything about the Flipstarter contract, you can import a registry that knows something about the Flipstarter contract, and your wallet can intelligently show you a list of all of the pledges you've made, and it can even give you a sum of the total number, the total you've pledged. And that can work for within a single campaign, or if we had multiple campaigns, it's possible to have a pledge interface that shows you all of the campaigns you have currently pledged money to, and when they begin and when they end, and how much you've pledged. And of course, if your wallet was able to support it, there would be a button to cancel your pledge, right? But even if your wallet doesn't have custom code for this decentralized application, we can at least be able to understand what is going on inside those NFTs. So they're no longer opaque blobs of data. Your wallet can associate meaningful names. It can decode them and associate meaningful names with what each bit of information is in those NFTs.
Perfect. Thank you so much.
Yeah, and there are a few other examples that the spec here mentions, but one is being able to show the user a table of their open orders on decentralized exchanges. Even if your wallet doesn't know how to use the decentralized exchange, if you used it on some other wallet and somebody sent you the receipts for that decentralized exchange, and your wallet would at least be able to be like, hey, you have X number of BCH sitting in receipts that are ready to be redeemed on some exchange. So at the very least, the user would have, the user's wallet would be able to tell them like, hey, you should send these tokens to some wallet that understands how to use this decentralized exchange because they're pretty valuable. And things like that are very useful to have across the ecosystem where all wallets can understand them in general. And there's a few other examples of being able to do a view of the user's tickets for, like, airline tickets or concert tickets or something like that, where it gives you times and dates and locations and such. And then also a gallery of a user's collectible NFTs, where you have like a picture and whatever for some game ecosystem or something like that. So it's possible to have a generalized sense of how NFTs work just from metadata registries, so that all wallets can have at least some view for every NFT. That's the goal, is to make it where every wallet can have something they display for every NFT. But and then some other high-level stuff. The entire system itself is decentralized. There's no central entity for how registries are published. Anyone can publish a registry. They can publish them on HTTPS. They can publish them as a normal website, or they can publish them via on-chain transactions, which is significantly more censorship resistant. You can't have your domain name taken. Your domain name is not your root of identity. Instead, you use Bitcoin Cash for the root of the identity. Some other details: identities are actually held by Bitcoin Cash contracts. They're held by the same kinds of contracts that hold funds and tokens. So you can hold the identity in a multisig wallet. You can hold it with an offline signer, time delayed vaults. You can use honeypots to reveal whether or not somebody has one of the keys of your identity. Everything that's available to the security ecosystem for Bitcoin Cash should also be available for these identities. And then very importantly, the validation of identities and the claims that the identities make, the public broadcasts that these identities make, like if you publish a registry on chain, the publication itself is actually SPV validatable. So we can, a light wallet can, with a couple of kilobyte document, a light wallet can verify that the registry that they have been using for several years posted a new update, and here it is. And all they need to do is check that the latest output is valid, and they can know that the whole history is valid. Yeah.
Oh, this works. The hand raising
yes,
thing works.
Definitely.
Okay, thanks.
What's up?
So I just wanted to ask, so the identities, I know this is something you've been thinking about for a very long time, but I want to know, when we talk about the metadata registry and the identities, are these things exactly interconnected, or are these independent entities that are useful by themselves, or?
Oh, yes. So they are useful by themselves. The identities themselves are useful. However, the way that we publish metadata registries is using one of these identities. You can publish a metadata registry as a HTTPS URL, but then you are relying on quite a bit of infrastructure in the middle to make sure that the user actually gets valid data. And if somebody slips in something in the middle and manages to convince a bunch of users that this token category is actually the stable coin issued by X company, now you've got a lever to steal a whole bunch of money from those people. So it's really important that we validate metadata properly. And a good way to do that is have the registries themselves authenticate and sign the have the identity that publishes registries, have them sign the version of the registry that they're publishing. And importantly, for example, if you just use HTTP and a registry doesn't doesn't publicly broadcast what the latest version of their registry is. It's possible for you to, if you're a kind of a rogue operator of a registry, you can send somebody a special version of your registry that's just for them as a targeted attack. And you can defraud them and steal a bunch of money. You can convince their wallet that that some token you're sending them is actually worth US dollars, or some token you're sending them is actually the stock of some company. But it's not. It's something you made just for them. It's a targeted attack, and they wouldn't even be able to prove that you targeted them because they contacted you on directly. So nobody else has a record of what you sent back, and the authentication of what you sent back is just what the DNS system said. Like, yes, they said that this is Jason's website, but I sent you something special. So to avoid targeted attacks, it's important to be able to have a public, like, non-renounceable broadcast mechanism where registries have to publicly broadcast what their latest version is, and light clients then want to always use the version that was broadcasted, so that they know they're not getting a version that other people are not getting. So it's just an ecosystem security thing in general. It's very valuable to have these light client verifiable public broadcasts of small bits of data. And in this case, we're broadcasting the 32-byte hash of the registry. You can either publish them via HTTPS or via IPFS, the interplanetary file system. And I'll actually start kind of skimming through this a little bit to show really high level how some of this stuff works. So we describe in the spec, we describe the concept of an embedded registry being a registry that you ship your wallet software with. So if you are the creator of wallet software, it is recommended you embed a registry. And this is just the bare bones basic what you should do if you have a wallet that supports tokens. If there are some very popular tokens in the Bitcoin, like right now, of course, there are no popular tokens yet. But in a year or two, there will be some tokens that are very commonly used. And it's a good idea for those to be in the embedded registry, so that when the user initially downloads your software wallet or whatever your indexer or whatever software supports tokens, there is kind of a very baseline understanding from the wallet of what it's looking at. We describe also this idea of manually imported registries. Of course, if your wallet is for more advanced users, you could allow users to be able to import a registry like from their desktop or from a URL. It's just mentioned here because you have to be careful about how you do that. And I've added some guidelines for doing it in a way that is resistant to phishing attacks. In a similar way where the Nigerian prince scam, thing, people are very good at convincing people that they can get lots of money if they just do this one thing. It's very important that wallets approach this clear-eyed. If you allow users to import registries manually and avoid some of the safeguards around authentication, that you make sure that users who are not very sophisticated aren't tricked by an attacker into importing a registry that is malicious, that the attacker can then use to defraud the user. So there's that. Moving on, DNS resolved registries are the first kinds of registries here that are updatable. So this is a very simple strategy for how to publish registries via the web using HTTPS. You publish a JSON document at a specific path for your domain, and the wallet should be able to, for example, like bitjason.com. If I posted a registry at bitjason.com, if you typed into your wallet that you wanted to add the registry from bitjason.com, it would go and fetch a registry from a specific point. It would fetch it over HTTPS, so it's secured. So it's known that at least bitjason.com at this particular moment in time believes this is the valid registry. And that actually lets us kind of bootstrap the system with trusted domain names. So there are domain names that are run by companies in the space that are already trusted by users, and ideally they can publish their registries make them resolvable by DNS, so that when you're first getting started, if you want to add a registry that, for example, I'm publishing, then your wallet can show, you know, a little check mark and the name of the URL, the name of the fully qualified domain name that it got that registry from initially. And from there, we can upgrade to the on-chain resolution strategy. But so this section describes a little bit about how to pull registries from using the domain name system. There's a specific URI that registries must be published under. It uses a very common standard now called the well-known URI standard. And it has a few recommendations for allowing cross-origin resource sharing and cache control headers and things like that, how to handle redirects. Moving on down here, so you have a registry that's published at bitjson.com or something. You've downloaded a wallet. You've decided you wanted to add a registry, or the wallet has a way to add it quickly or something. And you've gotten a registry that's a JSON document that is downloaded from bitjson.com here. Now your wallet sees that in the registry, I've included a field about the registry's identity. And so the registry itself marks that, hey, my identity is this 32 bytes. And it is a root of the identity. I will describe that here in a moment. But the idea being that you have first gotten the registry via the DNS system from a domain name you trust. Now we abandon the domain name system. We hope that it wasn't vulnerable. It wasn't hacked when we first grabbed it, but from now on, we don't have to continue relying on it. We can rely on-chain transactions and light client validatable proofs. And the reason we want to do that is, as I was describing earlier, you want to avoid, there's a number of targeted attacks that can occur if you continue trusting that, hey, this registry is always going to give me back an accurate data. You want to have something where they have to publicly broadcast that they were lying to people if they do lie. So there's some information here about upgrading to on-chain resolution. And now I will describe how chain resolution works. Any questions there about the DNS resolved registry stuff? I think that was pretty straightforward. But yeah, so the more of the interesting stuff is the fancy Bitcoin Cash interesting stuff is the chain resolved registries. So the way those work is registries are, I should say on a very high level, registries have a large list of identities that they associate a 32-byte identifier with information about the identity. And that 32-byte identifier is called an auth base here. The idea is that an identity is represented by a chain of transactions. We could call that the zeroth descendant transaction chain, but to keep it very simple, we call it an auth chain. And the auth chain has a base and it has a head, like a Git repository does. So the auth base is a transaction ID. It can be any transaction in the entire history of the chain. There are no identifying features about it. There's nothing you have to do with it. It is just any transaction. And what's important is what happened with the very first output, the zeroth output of that transaction. So if you start from any transaction ID in the history of the chain and you go to its zeroth output and you see where that was spent, and then you look at that transaction and you look at its zeroth output and you see where that was spent, and you keep doing that until you find a zeroth output that is unspent. That is the auth chain, beginning with that first transaction. So the auth base is the 32-byte identifier for this identity. And with that 32 bytes, we can have that 32 bytes. We can get a few kilobyte document that has the raw transaction chain, the whole chain of raw transactions that makes up that identity. And we can check that the first transaction when hashed is the auth base. And then we can check that each transaction references the previous transaction. And then the only thing you need to do to validate the entire system is the very last transaction. You need to check if its zeroth output is unspent, or at the very least, if that very last transaction is considered valid on the chain. If so, you know everything in the past there. Sorry?
When you say valid, you say this in your document too. We basically want to just validate the Merkle proof. The fact that it has been mined is the important detail, because if you get a document from somewhere else, you don't know if it's actually been mined. If you validate the last one and you check, of course, the list of transactions, each of them points to the previous one, then you know all of them are included in the blockchain. You just have to know that the last one is.
Yes, exactly. Yeah, so being able to, you're able to use the normal light client wallet infrastructure to just validate that last transaction. And if you can validate that very last transaction, you know everything else is valid because each one referenced a hash of the previous one all the way back to the auth base, which is what you knew as the identity. The auth base is the definitive, unique, globally unique identifier for an identity. Chris, yeah, did you have a question?
Yeah, thanks. I don't want to derail the presentation, so we can push this question off to the side if you want. But I'm just curious about the trade-offs of this process of validating the Merkle proof versus maybe just looking at the transaction history of an address. I have a similar system to this that I've been working on, and I'm just thinking back to SLP. Doing the Merkle proof ended up being fairly computationally intensive for really long chains, and that was like a performance issue. And so I'm just curious if you have any thoughts on that.
Wouldn't be the case here. You only have to do one Merkle proof check for the whole chain
at the very last. And for what it's worth, you also, I mean, if your system is such that the security properties are okay for you to be checking something based on just an address, in general, your system is probably not even going to be checking the Merkle proof. Like a system like that is probably okay to just ask the server that it's been trusting for address information. It can just ask the server if this transaction is valid. So actually the requirements are actually very, very low, even significantly lower than the requirements for checking an address. Because in this case, you only have to check one transaction at the very end that should be in the UTXO set. You can ask a pruned node if you're in a trusted situation like that. But the goal, of course, is that we build this whole setup so that it is possible for light clients to do it all with extremely low bandwidth requirements and nothing fancy. But was there another question?
Yeah. I just wanted to point out, with SLP, you had to do a lot of checking in between, just because nothing about the SLP data was ever had no consensus rules behind it. It was just OP returns. So with that, you sort of have to do. Whereas with this, that if the previous output was on chain, like if the whole thing was valid, then you just have to check the last transaction, which is nice.
Exactly. And that brings up a good
differentiate them.
Yeah, that brings up a good point. There are no features of these transactions. There's no concept of validity in the it's literally, in a sense, I'm just describing a primitive that's been there since the beginning of Bitcoin. It's actually not possible to create a transaction that does not have an output 0. Like every single transaction has an output 0. And so it's not possible to create a transaction that doesn't fit in the system. With the exception of it is possible to create a transaction that has an op return at output 0, in which case we consider the identity to be burned. So actually, if I scroll down here for a second, that's just a little detail that we add. So by describing the idea of burned identities, where you've burned output 0 of a transaction, we have covered every possible case that can possibly happen with these. Every transaction. What's that?
I was wondering about that because I like the idea that unlike SLP, this means that you can't accidentally burn your identity. That's beautiful because you could basically have a wallet that was very naive and you still wouldn't actually be able to burn your identity. But we have the concept of BIP69, which is the anonymity. It sorts the inputs and outputs. So, you can't identify which is the change address and which is the payment address. So it sorts them. And it basically sorts the outputs based on the amount you're sending somebody, which means that your op return will always be sorted as the first one. And suddenly it becomes possible to burn your identity. So I'm not quite sure if it doesn't warrant the simple, hey, if your first output is an op return, then actually be following the second one, something like that.
Yeah, that's something maybe we should talk about in an issue on the repo, because it'd be interesting to talk through. For right now, the way it's described, of course, is very simple to implement. Doesn't have any code paths, so to speak. There's only one possibility. So we'll have to think about whether or not that is a case we need to have a special case for.
And maybe a stupid question: why aren't you using cash tokens for following it? It's kind of an NFT, isn't it?
So actually, that's a great question. And it's possible to do that. It's no problem at all to do that. And in fact, if you want to ensure that a wallet can't accidentally burn an identity, you could do that. The reason that we don't is because it's not actually strictly necessary for this stuff to work. There's no requirement that it. And so what that means is that identities in this strategy, probably the most important thing to note is that this strategy allows for significantly better privacy than identities that use cash tokens, because an identity that uses cash token is, obvious to everybody on chain. With this system, you can have an unlimited number of identities. Every transaction in the history of the chain is plausibly an identity, and it's not possible to figure out which identity is making what broadcast. You have to figure out you have to know the auth base. You have to have a mapping between, like, hey, this is my friend Bob, and here's his auth base. There actually are like a dozen other transactions that, if you followed them with the zeroth descendant process all the way to something that's unspent, they would all share an auth head. They all have the same tip. Of course, because there are hundreds more transactions in the past than there are currently unspent transaction outputs. The chain has significantly more outputs that have been spent in the past than are currently unspent, and so that means all of those could point to something that is shared. Yeah, that's a good question. The reason that there's not any sort of, I haven't tried to define any sort of required standard around it is simply because it's not necessary. It's something that you could do for application-specific use cases, if it's like super critical that you don't accidentally burn an identity and there's a chance somebody would be sent it for some reason, then that's probably a good use case for defining kind of a higher level standard like that. In this case, it's not strictly necessary though, so we don't have to put it in at this level of the specification, so to speak. Was there another question? Also, I saw a hand raised a moment ago. Was it Sahid, maybe?
Yeah, Sahid.
Okay. That's right. I'll continue on. Let me know. Yeah, so I think we have described the zeroth descendant transaction chain. We've described the process of getting from a 32-byte identifier to the latest broadcasts of an identity. Yeah, is that pretty clear? Is there any questions about how we get there?
Sorry, that was I just dropped out, but that was Chris asked the same question I was going to ask about that.
Oh, fantastic!
Using cash tokens.
Awesome. Was there another question? I think we did. Yeah, Callan.
Just naive question, which I think I might know the answer to, but I'm just going to ask it anyway. So you'd want to follow the zeroth, you'd want to follow the identity along to the latest in case there are updates or something like that to the metadata, or
yes,
or in case someone wants to give control of updates to somebody else, or
yes,
yeah,
exactly.
I mean, it can be changing in time, right? So that's why
exactly.
you want to
That's
be able
the whole
to publish updates or whatever. give custody. Okay, got it.
Yeah, precisely. I mean, if you think about it, look at it sideways. If you think about it, this is the purpose of Bitcoin in general, is to be able to keep track of identities like this. In this case, we just associate numbers with them and call it money. But keeping track of the changing security requirements of identities, where I can move the money from this public key to this public key, and then I can move it from there to a multi-sig address, and then from there I can move it to some other more complex contract, and I can move back to single sig. The blockchain itself, the whole system, is just a giant database for keeping track of the changing security requirements of these identities, and of course moving numbers.
But also, like the identities. So I mean, these transactions that are part of that chain, they can update the metadata. I guess that was implicitly stated, right? Is that something that can happen?
Yes. So that leads on. Yeah,
Okay,
I haven't even mentioned. I haven't even described it.
Yeah. Okay.
So that's good to. I'll scroll right down to that. So we just talked about how we develop these chains. Now we can talk about this idea of an on-chain identity claim. So a claim made by an identity that is publicly broadcasted on chain. It's quite straightforward. In the latest transaction, when you spend your output 0, you spend it forward, you migrate your identity to another transaction, you can stick an op return in any of those outputs. And we call those on-chain identity claims. And those can be very useful for stuff like hashes of software updates. So I have some examples here. Hashes of software updates. For example, a Bitcoin Cash node development team could, instead of using PGP signing of releases, they could have a signing identity that is a multi-sig of all of the people who would normally be PGP signing it. And so in order to in order to move that identity, to broadcast a new claim of that identity, you would need a signature from enough users, or the fallback method, or whatever. It's just a normal Bitcoin Cash contract. And that transaction can include an op return with a hash of the software, or with a hash of like a JSON file that has all of the hashes of the relevant builds. So with this setup, it's actually possible to track an identity forward in time, even with changing requirements. Even if you lose a member of the team or whatever, if somebody leaves and you have to swap them out of the pool of multi-sig signers, you just move the identity forward, you add the next person, you pull out the other person, and now when you broadcast these on-chain identity claims, you can broadcast the next hash of the next release. And of course, if you've got a node software, your node software could even find that automatically and tell the user there's an update and it's been signed, right? What's cool is that there's it's cool is there's a definitive, correct, completely verifiable way of there's a completely verifiable way to confirm that it has been signed adequately. Like if something is broadcasted by an identity claim, that the whole release team agreed to it, right? Because otherwise they would have defined their multi-sig differently so that it requires 4 of 5 of them or something like that. So just having an absolute definitive way to have a multi-person identity be able to broadcast a claim means that we can automate systems like automatic updates and stuff like that in a really secure setup. So that's quite cool. Also things like warrant canaries, tamper-evident logs, being able to broadcast reusable payment addresses that are trusted if you're like rotating reusable payment addresses. And then onion service addresses. Actually, there are a lot of Tor services that get hacked or taken down or whatever, where they use a PGP identity. They use a key that is a PGP key to represent their identity. But then when they get hacked, now you don't know if it's the person who was running the website before, or if it's the attacker that you're talking to. And they publish like, hey, here's our new address, and it looks the same, but you don't know if it's now, is it the same people as before, or is it a honeypot? Is it the attackers? Or like, so with this setup, we can keep track of identities over time, even with changing requirements. And it's possible to do stuff like have the identity information be in offline wallets, and you only use like a warm key that's part of these on-chain identity claims, or even standardizing where output 1 is the one you sign with, but output 0, of course, is the one that is important for the concept of the identity. So there's lots of other use cases for the general identity primitive. The only one we use with the metadata registries is this one particular publication output. We have a way to do a publication output. It looks like this: op return capital BCMR for Bitcoin Cash Metadata Registry, and then the hash. Was there a hand? Oh, yes, there's a hand. What's up?
Yeah, I just wanted to mention before we, since it's coming up right up next, there is also another use case for those identities, and it might be useful for connecting with the node, an IPFS node. So they have public keys going on. So when you actually connect to an IPFS node,
Nice.
they have an identity, and it'd be interesting to go ahead and because those are actually really bad. It's terrible UX to actually go ahead and transfer that key over to another computer or another server and whatnot. And so it'd be interesting to kind of go ahead and do that, revoking and granting new access when you connect to a the same identity basically behind the scenes, but it's just using a different key. So literally the same exact use case.
Yeah, fantastic. Yeah, that's a great example. Things like that where it's a peer-to-peer protocol connection information, where you want to have a definitive correct way. You can look in one place and you get the right answer. That there's a lot of value there. If you already know their identity in the Bitcoin Cash system, if you have their Bitcoin Cash identity, you should be able to get whatever else info you need there. So yeah, it's a great example. Tom, did you have something to add or a question?
Yeah, I wanted to boil it down a little bit, because something I observed a couple of days ago. When we are talking about the very complicated technical manners of how it gets encoded on chain with the zeroed output, etc., what this basically means is that you could have a new wallet, essentially, that is a view-only, an address-only wallet, and it would basically update the chain as normal, and it would that way just collect all the transactions that are your identity. So you could very easily have a normal wallet that already does all of this for your private stuff, but then a view-only, monitor-only one for identities. And so it uses the same components, the same ideas, and you could just push all of the identities of stuff you care about in that wallet, and you would have an impossible to fake identity that you just get from the chain directly. I think that's a very powerful idea, and that works even for SPV wallets. You don't need to trust any third parties or whatever to know that what you're looking at is correct.
Yeah, exactly. Yeah, that's very exciting, just to have a source of truth for even for light clients. Once you have their identity information, and it's literally once you have associated a person or a entity of some sort with this 32-byte identifier, from that moment on, you have a light client validation strategy for following them forward in time. So that's very powerful there. I actually had some graphics there in case anybody was curious. I think that this was pretty obvious, but right, we call the whole thing an auth chain. And these are an example of kind of representing the concepts we talked about already, but auth chain is the title there. This whole thing is an auth chain. The first transaction is the auth base, and the last transaction is the auth head. And all that matters is where the 0th output goes. And from there, you construct the whole thing. So, and then as I meant to show this also, you can see here an example of merging identities. Something that just an emergent property of the system is that identities, of course, identities can't be split, because you can't spin off half of a person or something. If you're a company and you're doing a spin-off, what really needs to happen is, one of the sides of the spin-off retains the identity, and the other one just broadcasts, and that one broadcasts like, hey, here's our subsidiary we just spun off. But you can see it's possible to have two auth bases that actually resolve to the same auth head. I just wanted to show that in this little graphic I put together. Yeah, so I think we can continue on the metadata registry publication outputs. So we talked about how on-chain identity claims are how identities can broadcast things on-chain. And we use them for these metadata registries. We use these on-chain claims to verify the latest registry that's been published by the identity. And I talked about earlier that that's important for avoiding targeted attacks. You want to make sure that the registry isn't delivering you a special version that's just for you, that is intended to defraud you. You want to be looking at these publicly broadcasted registries, so that at the registry outputs, so that at the very least you can prove that you were defrauded this time by this registry, and you can stop using them. So there's some technical details for how these outputs are put together. They're quite simple. You can publish registries either on IPFS or HTTPS, and we standardize both because it's very important that we include the hash on chain in order to prevent those attacks. So there's some notes here as well. Yes, so I think that covers all of the on-chain mechanics. So we can describe now just the JSON schema. So this is pretty straightforward. It looks a lot. There's several other cryptocurrencies actually that have somewhat similar schemes where they have just a JSON document for describing this stuff. You'll notice if you look through the JSON registry here, and actually there's source TypeScript definitions. Oh, nice. I broke the link a moment ago on this page. Excellent. Here we are. Here is the source TypeScript definitions. You'll notice they're very thoroughly documented. There are there's tons of documentation and tons of examples in each field, and it goes all the way through. It's almost all comments. But I'll give a kind of a quick overview. So we talked about how identities are really important here. So identities are the core primitive for metadata registries. Metadata registries are JSON documents with a version, optionally a registry identifier, which is just the auth base that the registry claims is its own identity, and then a giant mapping of auth bases to identity information. And that is what a registry is. It's just a set of mappings from these 32-byte hex identifiers to identity information. It is important for wallets to be able to represent the concept of the passing of time for these identities. And so one place where we differentiate a little bit from, there's an Ethereum standard that's similar to this called ETH tokenless. Cardano and a few others have some standards like this that differ in various ways. But something that's kind of unique here that I should note is we have this concept of identity snapshots, which you may recognize as mapping pretty well to our off-base or off-chain primitive, where you have a transaction that broadcasts a new version of the identity or a new claim of the identity. The registries themselves also let the registrar represent the evolving timeline, the evolving history of an identity. And what matters is what the last one is. In general, what matters is the last one. However, if a user hasn't opened their wallet in a year and a company rebranded, that's an opportunity for the wallet to say, hey, this company rebranded since you opened this wallet. They're no longer called this, they're called this. We've updated the information. Here's the new token icon, etc. And the same is true both for identities that we've talked about and also for tokens. So tokens do regularly rebrand on many chains. They also have to, for technical reasons, change their technical identifiers. Like if it's a centrally managed token that's like a stable coin, if it represents gold in a vault in some country that is issued by a company, but that company, like a hacker, manages to get control of their reserve. This has happened multiple times on other cryptocurrencies. What we want to ensure is that our ecosystem can handle that situation in a relatively smooth and orderly way. So the way that happens then is you can actually update in an identity snapshot. You can update the token category that represents that token. So in this case, it's an identity that represents a token, has a name and a ticker symbol and an icon and whatever. But they were hacked, and so they froze withdrawals or redemptions or whatever, and broadcasted publicly, "Hey, we were hacked. Everybody, stop everything. Don't send anybody your tokens or whatever. We're gonna have to reissue tokens with a new fungible token category, starting this day, whatever." And there's an upgrade process, and it's a big process. We can represent that very simply by being able to represent that there is a new snapshot for that identity. And you can change anything about the identity can change in that snapshot. And in this case, it would be the category, the token category. So I just wanted to, does that make sense? Is there any questions about that detail? Yeah, so and of course, the goal with this is that wallets can use that historical information to make more intelligible experiences for users. So if a user hasn't logged on in a long while, as I was mentioning there, that's a good opportunity for a wallet to say, "Hey, this token you're holding is no longer called what it was called the last time you opened this wallet. You now have this token. Here's the new icon, whatever." And if you clicked on it, you'd be able to click on details, and you'd be able to see a little timeline saying they rebranded on this day. Like being able to have that information represented in a structured format is very valuable for the wallet ecosystem. So that kind of covers a lot of what's described here: identity snapshots, identity history, a few other details. Yeah, there's name, description, tags, and URIs are kind of the only properties that are used in a lot of places in the registries. Your registry, an item in the registry can have a name and it can have a description, and that's very consistent across lots of parts of the registry. Identities can be tagged, so that's just a detail. A lot of token systems and a lot of metadata systems across various cryptocurrencies support tagging systems. Therefore, discovery or for as described down here, actually, they can be used by clients in search, discovering, and filtering of identities. They can also convey information like accreditation from like investor protection organizations or public certifications by security auditors or whatever. There are a number of if you want to have a badge of some sort that is associated with a set of tokens where there's an auditor that goes and reviews these decentralized contracts, and they're like, "Hey, this has been reviewed by our security team." Being able to represent those associations where there are multiple identities or multiple token types that share a tag, we have that as a basic building block. And then I guess the only other kind of element of the system that is available in the registries is there are properties that are labeled URIs. They are objects that associate a short lowercase string with a uniform resource identifier with a URI, and that by default, as part of the standard, all clients are required to support both HTTPS and IPFS for any of those URIs. Notably, and we mentioned in the spec here, rudimentary support for IPFS can be implemented with HTTPS. So what that means is that it's actually possible for any client to just support this stuff with just being able to support normal links, HTTPS links. So little detail there. There are some recommended URI identifiers. This is how we do token icons and all types of icons. So if you have an icon for an identity or for like a software signing team or something like that, it's under URIs.icon, and then it is a URI for the icon. There's some details there. And then there's a standard web identifier, which should be some sort of navigable resource, a website or something, offering information about the registry, the identity, the tag, or whatever it's about. And then there are a few other identifiers that we basically reserve. They're optional, but we want to have them fairly standardized. And these are fairly standardized across lots of cryptocurrency ecosystems. So I I've ensured that they will be that there's a place for them here. And then yeah, Chris.
Yeah, sorry. I noticed that in the schema document, the JSON schema document, most of these properties are listed as objects instead of arrays. Like would like I'm thinking specifically about the URIs. Wouldn't that want to be an array of objects rather than one object?
They are. That's a great question. And the reason that we just in many cases, things are objects rather than arrays is because the identifiers need to be unique. So you need to make sure the idea is that we want at a protocol, at a spec level, it's not possible to define two icons.
Oh, I see. Okay, so you're essentially okay.
Yes,
this makes sense.
So that's the only reason. Like, and many, when you look around the JSON spec, I've been very careful about defining things in ways where the format itself cannot represent invalid states. So we don't have much validation. It's structurally impossible to accidentally put two icons on your on a single identity. Instead, you need to have one that's called icon and one that's called icon HD or whatever. That might be like a vendor specific identifier. So, and I that's a great, it actually brings up, so there are a lot of very open-ended sections of the schema, and those are intended to be extremely open-ended, where they will be vendor-specific. There will be wallets that have their own thing. We actually standardized a weird one here called icon-intro, specifically because there are other, in various cryptocurrency ecosystems, there are ecosystems where some tokens are starting to use animated icons. And by spec, the icon up here is not animated, and wallets can expect that it won't be animated. And there is one that is a standard animated one. So if you want to add an animated icon, we have standardized it as an optional thing, but it won't be just random icons with animation spam to get people to look at them in your wallet. So there's some things like that I've been super careful about making sure we have the way that the format works ensures that you don't use it, that you use it correctly, and where there are weird things you could do, we've standardized how you should do those things.
Yeah. So if I wanted a non-standard identifier like cat, it would just be like a .cat because it's an object.
Exactly.
Yeah.
Yep. And actually, so for example, some common identifiers include Discord, Docker, Facebook, GitHub, et cetera, et cetera. So that's where you would put like your Twitter URL and stuff. So okay, by necessity, by nature, we don't standardize any of that stuff. That's all under this custom URI identifiers. We don't want to have any sort of vendor specific standards. However, if you put, if you put the identifier Twitter in a URIs field, most wallets are probably going to render that as an icon and it'll be clickable, right? So but in general, the reason that we have the URI section is so that you can convey information that is intended to be clickable, that is intended to be a link from here to somewhere else. And it might be, and we mentioned also, it might be for sharing social networking profiles, peer-to-peer connection information, and other application-specific URIs. And specifically, there are a lot of like peer-to-peer applications that have special URI standards, where this is exactly where you would want to have that URI, where you'd be able to click a button from a wallet and it would open up some other app immediately. So just having a place in the spec where that kind of vendor-specific stuff can happen, but it doesn't have to be part of the standard and it doesn't have to be supported by all clients. That's the goal. Yeah, Callan?
Yeah, a dumb implementation detail that I just noticed. The URI, it seems like the regular expression for the acceptable characters is a subset of what is considered a normal URI set of characters. Is that intentional or is that?
That is the identifier. That is for the string.
Oh, sorry. Okay,
yeah. Yes, you got it. Yeah.
That's identifier, right.
Astute, you noticed. But yes, that the idea is just basically by convention, it should be a goal that all URI identifiers maintain that kind of lowercase snake case or cabal
Okay.
case, I guess.
That's the key, right? Not the value. Gotcha. Okay.
Yeah. But that just means that it's a lot harder to accidentally have, like, one icon, one identifier where it's lowercase icon, and one identifier where the C is capitalized, right? You want clients to be able to come to a consensus on which one is the right URI for that identifier.
Right. Makes sense. Yeah.
But yeah, so I think that covers a lot of the basic stuff. And then, as we were discussing earlier, there's a concept of extensions. There are a number of places in the spec, and this is actually similar to how a couple other token systems work. The Ethereum token list has one, and a couple of the other cryptocurrencies have metadata registry standards that have an extensions field. And of course, a lot of other protocols also have JSON protocols have extensions fields like this. But the idea with these extensions fields is they are completely unknown as to what is in there. You should use a lowercase identifier, but in general, it's going to be vendor specific. So there might be a couple wallets that will all try, all to get together and say, hey, we're going to do a contact extension. It works like this. Here's the standard, and they can all implement that. But in general, it's not required for clients to be able to implement that for them to understand these registries. So the goal is to have a really basic, like the most minimal possible standard for the Bitcoin Cash specific stuff. And then everything else can go in these extensions. However, there are two extensions that are standardized right from the outset as examples. One is locales. So under extensions, you can have locales, which then should use a Unicode locale identifier for that lowercase dash separated identifier. And that is how you would translate a complete registry into another language. So by convention, all metadata registries are provided in the English Unicode locale with the identifier EN. If you want to localize it further, you put the localizations in the locales extension. And that includes even for English locales. So if you need to localize for EN-US or EN-GB, you put that in the locales. So in many cases, a lot of registries are just going to be one set of information that are by definition are for the EN locale. You don't have to have an English translation. Also, we even say there it's acceptable for registries to be partially localized, and that means it's also acceptable for you to have no English anything. You can just, at the very top level, you have extensions, .locales, and then you have the registry in Japanese or whatever. And you don't have to have an English translation. But in order for wallets to be able to understand what they're looking at, it's important that you have some high-level way to describe what they're looking at. And a much simpler way of doing localization, even than tagging things, is kind of the way that is this, where you have, if you support another language, you would look in extensions.locales for the contents to use for that language. And we also have an algorithm for deriving the most localized possible info for a particular user. Any questions there or comments? So that's an example of an extension where many clients will not support that extension, but the ones that do need localization, now we have a standard way that happens. Then the other extension that's standardized, there's one other. It's the off-chain extension, and this is how we provide. This is how we can provide very efficiently all of that off-chain information for light clients, so that they can grab this registry and have all the information they need to validate whatever identity nearly instantaneously. So instead of having to do kind of a chain scanning activity, the registry can actually give them the kilobyte or whatever of data that they need to verify that the registry is not lying to them. So this just describes how to serialize it, put it in there. And in short, it's that you provide an array of strings that are hex encoded transactions. And that's it. Yeah, so there's some guidelines for token issuers and for client software here, just like how to, for token issuers, I'll say one thing that's notable. If you're issuing fungible tokens, this recommends that you hold your reserve supply in your auth chain in that 0th output, so that light clients can actually, looking at this the auth chain itself, they can actually verify definitively what the maximum possible circulating supply is for your fungible token. So it's a recommendation. If you're a fungible token issuer and you want to do that, you can. Obviously you don't have to, but if you don't do it, then these light clients can't prove that the circulating supply is what you say it is. So it's something that likely will be an emergent standard just by how all of the tech works. It's just something that is emergent from the other properties. Callan?
Yeah, so just to slow down, so you're saying that if the auth chain, like the Genesis transaction for a token,
Yes,
is involved in the auth chain, like it's part of it. You're basically that way a client can look at the beginning and see how many were created or minted or something. Is that what you're saying, or am I
yes, and actually, for token issuers, if you're just doing an identity with this stuff, you do any transaction ID. If you're issuing tokens, these things fit together very nicely. It's a good idea to have your auth base be the category, be the token category. And you can do that very easily by you can either use the way that here I can describe it here. Callan knows this, of course, but for others, the 0th output of a transaction is the one that lends cash tokens their category ID. Like the way that a token gets its identifier is looking at is valid identifiers are outputs that are spent that were 0th outputs of a transaction ID. And if you spent that 0th output of a transaction ID, you're allowed to create a token with that identifier. So it's just a really simple strategy for handing out identifiers where there is only one possible output that could control it. And that's how cash tokens works. And this stuff fits really nicely into that because, as you can see here, a cash token Genesis output is technically works with this same auth chain system. You could consider this to be an auth chain. In fact, what we're looking at here, you can consider the top one to be an auth chain where this is the auth base and this is the auth head. And actually, this is also a valid auth base that would resolve to this auth head. So they both, you're spending the 0th output from 2 different transactions in this transaction, which means that there are 2 different hypothetical identities that would resolve to this transaction ultimately, if you were looking it up that way. So yeah, in general, if you are issuing tokens, it is probably a good idea to at least start where your auth base, like the root of your identity, is exactly equal to the category that your token uses. And if you do everything right forever, for many types of tokens, you will never have to have them different. The category will always be the auth base. The issues come about for a number of other reasons. First, of course, if you're a trusted stablecoin issuer and you're hacked and you need to revoke all of your reserve supply and freeze the asset structure right then and reissue all those tokens and let people pull them from your website or whatever. That's happened on multiple cryptocurrencies. So that's something we need to think about in this standard. We need to make sure that that doesn't hurt too bad to do, and wallets can handle it reasonably. So dealing with hacks where you have to do that, or if you didn't issue enough fungible tokens initially and you need to issue more fungible tokens, you need to change your category. You'll have to upgrade that way. There are also a number of other smart contract reasons, decentralized application reasons, why a token category might need to change. A very notable one is dividend issuance. There are a number of ways to issue dividends to fungible token categories. So if you represent stock with fungible tokens, there are a number of ways to issue those dividends. There are some really nice ways to issue them that are very deeply compatible with the decentralized application ecosystem, but they require you to change categories for the token each time you issue a new set of dividends, so that you have a set of token holders who have already gotten their dividend and a set of token holders who have not. And I'll note that the way the traditional markets handle this is they actually have a list of people who owned the asset as of closing at a certain day, and they close all trading across the world, and they take account of who had the money, who had the stock at that time, and then they send people their dividends, and it takes several days or whatever. It's possible with the cash token system to have a iteratively issued dividend where token holders from before the dividend issuance can have their tokens, and they can have it on a decentralized exchange or whatever, and it can be trading actively. And so you can't just blast the money to everybody who has some tokens in their address, right? Because it might be a decentralized exchange, it might be a custodial thing. It's typically a bad idea to just send the money to addresses. But a very safe strategy is have a way where wallets can just bring their tokens to a contract that is the dividend payout contract, where the company just deposits all the dividend money in this contract, and you bring your token at your leisure and get your dividend. And it might be like 5 years later. Like you might have your tokens in cold storage, and there might have been a dividend payout quarterly for the past 6 years or whatever. And you pull that out of cold storage, and your wallet's like, hey, you've got 40 dividends to collect. Here they are. And your wallet then goes and hands the fungible token to the contracts that are just holding this money, waiting for token holders to come redeem it. And your wallet would then just be able to go collect all of your dividends. And that lets us issue dividends. That lets a company issue dividends without having to stop trading globally and pause everything and take account of all of the owners and have their full names and stuff like that. So it's a possibility, but so I'll note that there are other reasons that it could be valuable for a token's category to have to change, but the token's identity will want to be the same. So it may, for many cases, as Callum was talking about, for many cases, they may begin where the auth base is the token category, but years later, it would definitely be different in many cases. So, and of course, you want the token name and the icon and the symbol to stay the same. So that's why we have to have structured systems for doing that. But I think that covers all of the big stuff. There's a few other notes for how to handle migrations safely and some other things, but that covers this chip. So any questions? Yeah, Emergent.
Oh, sorry. Yeah, I have 5 questions that I've saved up.
Yeah,
no, they're pretty high level ones. So maybe I'll just ask one at a time, and you can skip to somebody else. So just as a recap, this is a technical presentation, right? So but at a high technical level, I think there were 2 main parts here. There's the identity, and there's the registry, the metadata registries. Is that correct?
Yes. Yeah.
And then sorry.
Yeah, well, you got it. Yeah, so and identities are important for being able to authenticate registries. If we want to authenticate registries better than just like, hey, it's at this website, then we need the identity primitive.
Right. I know you buried the lead here. Like you've got the whole identity system.
I took it. Yeah, you have to understand how to resolve it if you want to get the authentication correct. But and then then the other connection, of course, is that the registries themselves, they really just represent a mapping of identities to of auth bases to identities, and tokens are among the identities that are possible to represent. But it's also, you can also represent registries and companies and individuals and things like that.
Okay, actually, that was the sub part of the question. Is so as a technical presentation, there's the registry and it's the mapping of those things. What about the identity? What are the next, just one level down? What are the components of an identity in the system that you've described?
Yeah, there are 4. There's a name, a description. And here, let me. Well, I could share this. Well, I'll just read it from the spec. If you're curious, in the spec, in the pros spec, it's under the identities section, under metadata registry JSON schema, identities, identity snapshots, name, description, tags, and URIs, and then also extensions. So there are 5 there.
It's fundamentally a controlled by or owned by a single private key, or I mean, at any given time?
At any given time, it's owned or controlled by a single output would be
No,
the best way to
output.
describe it. Yeah,
Got
and
it.
it's the 0th output of a particular transaction
Right.
at any
Okay,
moment in time.
perfect.
And so you start from the auth base, and you can trace all the way forward, and the current owner is output 0 of the unspent transaction at the end.
Okay, so the identity is hyper efficient and also extremely easy to look up and authenticate. Yep. That's very cool.
And it's you can, as an identity owner, if you own an identity, and you're trying to give people like, here's my identity, here's the history of it, you can actually say, here's the auth base, and you can go ahead and give them the 2 kilobyte document or whatever they need to trace it all the way to the beginning. And then if they're a light client that can only validate like, hey, is this output unspent, by checking the same way that any SPV wallet would check, they can still verify your whole identity and they get a massive head start if you hand them all the documents.
At least the current. Okay. All right. Can I ask another one?
Extension, by the way, that auth chain extension is to hand you all of those transactions. So those two standard extensions we talked about. There's the localization one, and then there's the auth chain one, which provides that basic data to get those light clients from the beginning to the end very, very quickly.
Right. Okay. Let me ask one more, and then I'll take a break, and I'll come back and ask more questions.
Definitely.
So as we discussed separately in the earlier today or yesterday, this chip is not a consensus chip, so I understand that. However, you're proposing a standard that if this gets adopted, that's a very big deal and needs to be done very well. And one of the roles of the chip owner is to absolutely murder their own child and try to kill it, right? It's steelman the proposal. So what's like your biggest worry so far right now about it? Like what do you have concerns about, or like, I'm not so sure about that, or
that's actually that's a hard question, because in a lot of cases, like, I could give you a good answer for pretty much all of the other chips I've written, because they have like clear, risks and
right,
and trade-offs and stuff. In this case, because it's all like wallet layer stuff, like if this isn't good enough, like wallets are just gonna change one little thing here and be like, hey, this is the one we're using, and eventually we will kind of standardize on something. There's a good chance that this is going to need to. So maybe my answer would be there are a lot of moving pieces, and there's more detail here, I would say, certainly more detail here than it has been in any of the chips so far. There are other protocols, other standards that are sort of like this that have happened on Bitcoin before. The payment protocol, for example, is kind of at this level of detail, of technical detail, where even though it's not a consensus thing, it's something that it's important for all the wallets to kind of understand. And as we've seen with payment protocol, there were improvements to it over time. There are sort of competing payment protocol standards. So in that sense, it's easier to say that there aren't really any risks here that I'm worried about, because the worst that can happen is people don't use it. Right.
The worst that can happen, right, is it gets massively adopted, and then it's like, oh, there's that thing.
Yes. Is it's missing some, where it's critically missing some important. Yeah, so it's something
like,
we should talk about.
The beautiful thing, PGP, it's just amazing, right? So
right. Yeah. Yes, exactly.
It had some holes. It had some issues.
Yes. Well, and I'll note that, in the PGP example, one of the biggest issues with PGP is PGP suffers from its failure to solve the double spending problem. The PGP in general, all web of trust systems like that, typically basically always fail the moment after your signing party. You don't know if that person has lost their key, and if they need to update it or whatever. And if they try to send you a new update, you don't know if it's an attacker, right? So the moment you walk away from somebody after a signing party, your signing party has become pretty useless, unless you really trust their technical prowess. And that has been the Achilles heel there. So the very same reasons that makes that the double spending problem being solved in Bitcoin Cash is valuable. That's the same reason that this identity system can outperform PGP in that case.
All right, I'm gonna take an NFT on coming back to redeem on biggest worry in the future. I'm gonna hold on.
There you go.
I'll come back to it later.
Yeah,
All right.
it's something we should definitely talk about. In the issues, please. If anybody has thoughts on like how do we apply this for this specific use case, we should talk about specific application use cases and make sure that we figured things out. I think in general, though, maybe one of the other reasons it's hard for me to pick out something I'm specifically concerned about is because the schema itself is very basic. The stuff that is actually standardized is stuff that has like a pretty clear, correct answer. And
the part that makes me the most nervous is the identity, because I mean, you're talking about very fundamental.
Yes. Yeah.
Like
the underlying primitives. Yeah.
Roots of the earth kind of issues there. So
yes.
Yeah. Okay. I have several more questions. I'll wait until later for those.
Cool. Yeah. We'll rotate around. Ben, did you have a?
Yeah, Jason. I mean, this is great stuff. Really expressive, stuff. I've been following your work with all the predecessors of cash tokens since I was working on the multiple op return things.
Yeah.
So, like, you got.
Well, and you'll note here,
multiple op return is like the simplest chip you could possibly do, and I know what hell it was to do that. And you've got so much going on, and this is really great. And
you'll appreciate that on-chain identity claims. Thank you very much for making the multiple op returns happen. And one of the reasons that I was so in support there was this. And you'll actually find links to some of the predecessors of this work because of it. It makes it easier to do on-chain identity claims if each different protocol can have its own output standard. So the metadata registries has an output standard for how metadata registry publication outputs work. But if we couldn't have multiple op returns, then like merging them would be silly. And I mean, I'll note it. Yeah. Anyways, op return is a beautiful hack. It is the most correct kind of hack. It is precisely the way you can associate a piece of information with all of the identities that take part in a single transaction. I think there are a lot of it's very there were discussions about making a multiple op return output format and stuff like that, but I think that misses the forest for the trees. That the transaction format is precisely that is what the transaction format is. So being able to have multiple op returns was really, really nice there. But yeah, so thank you.
I'm glad that worked out for you, because
that's very important for this spec, I will say. But
my use case got destroyed because SLP got whacked. But I'm hoping, and it kind of got destroyed because the main wallet provider abandoned it, Bitcoin.com, which gets to what my real question is with you. And it's like, how do we get the adoption? I mean, have you been talking to the wallet implementers, and who do you have on the wallet side who's willing to implement this stuff? Because that's it. That's what makes or breaks this.
Yeah, that's a great question. So the basic stuff. I'll say I don't have any names that I think I can share immediately. Some of them are on this call. Some of the wallet providers that will hopefully be implementing. Of course, there's one that's already implemented tokens on this call. Callan has already implemented tokens in Electron Cash.
Or at least there's a branch. I still have to finish.
Right. Yes. Yeah. Exactly.
It's basically working.
and of course, as part of that, if you go to implement native tokens in a Bitcoin Cash wallet now, something you come up against immediately is how do you put an icon and a name and stuff on there. So in general, this is something that was important to get out before the lock-in period for this November. Just that there are some clear ideas, some clear, well-defined ideas that the wallet ecosystem can start running with, on November 16th. Most wallet providers need something like this if they're going to support tokens. So the question is whether or not they support tokens. And of course, I'd leave that to the cash tokens chip to push them to do so. Yeah, and there are wallets that most certainly already either have branches or have plans to implement cash tokens very soon.
All right. Well, this is a very elegant solution, very expressive, man. I'm excited to get a chance to try it out.
Thanks. Yeah. Oh, Chris, did you have a question or comment?
Yeah, and first, before I ask it, I need to apologize to you guys because I'm not as educated as I think most people on this call are on SPV mechanics and Merkle proofs. But so hopefully we can answer this without giving me a crash course in that stuff. But I'm just thinking, if there is, say, 1,000 transactions between the auth base and the auth head, the tip of the DAG, is there a way to quickly verify that the head is valid and resolves to the base without actually downloading all those 1,000 transactions?
Yeah. So I'll answer the quickest answer is when you first get the identity, you if the auth base that you get for the identity is thousands of transactions back, there is no faster way than to download all of those transactions. Note, most of those transactions are between 200 and 300 bytes. So we're talking about like 10 kilobytes. We're talking about significantly smaller than the average icon size for most tokens.
Sure.
So really the hassle is where you get it from. But what's nice is that data is extremely verifiable. So you can get it from a completely untrusted source, and you'll know definitively whether or not it's accurate because you just check that last transaction. So we do have kind of a sweet spot here of the chain itself, even if it is thousands or actually like millions of transactions that it's been. There are a few places on chain where if you start at the beginning and you trace it, you can get to like a few 100,000 or something, where they're like the gambling websites in the early days and stuff like that. Even for those, the proof document is like a couple hundred kilobytes or whatever. It's smaller than the average image that's being loaded into wallets already. And most importantly, that proof document can be, you can get it from absolutely anywhere, and all you have to do is check that last 500 bytes or whatever. Each one references the past one, but getting from auth base to the tip, you just have to validate the very last transaction. And then I'll add also, once you have done that, it's perfectly reasonable for clients to throw away the old auth base and use the latest transaction that they know. You don't need to resolve all the way from the back every time. Like if you've done that before, you just update. You know that their identity goes all the way to here. When that has 10 confirmations or something, when it's not going to get reorged, you could go ahead and change what your view of their auth base to very recently. And of course, when you validate, if they make changes, you only need to validate that one transaction. You don't need to.
I wanted to just clarify one extra detail there. Chris, you said DAG, and that's technically correct, but it's really just a chain.
Yes.
Right.
Thank you. Yeah, I was going to mention. Yeah, it is a list.
Yeah,
there are no forks. And if anything, it's a chain that can have multiple inputs. There can be multiple chains that lead to the same spot, but they can never break apart.
Yeah.
Okay. So.
Yeah, technically you can have like the actual transaction IDs to the Merkle proof, kind of like cash, all the kind of like these distributed as well, because you can get really the information from anybody. And
I also didn't mention like how SPV wallets. They're actually multiple strategies for light clients. I now say light clients instead of SPV. I'll say SPV occasionally because people recognize it as a term, but there are a number of different ways to do light clients. There's the BIP 153 and Neutrino and progressive knockout filters from Mark Lundeberg. There's a number of other strategies that are significantly more efficient than SPV these days and have better privacy properties. So that's a deep topic. And
I didn't want us to go down that rabbit hole.
Yeah.
You've answered my question. I appreciate that.
Yeah. So if it sounds like I'm hand waving over and saying, and then the light clients do what they have to do to check that last transaction, it's because I'm intentionally hand waving. There's like a dozen different ways you can do it. So that hand waving is very deliberate, and I don't intend for there to be a correct answer when I answer it. Like, there are a number of ways you can do it. One of which is you use whatever trusted server you're using, and there are wallets that just use trusted servers. Like, in fact, a good chunk of other cryptocurrency ecosystems use nothing but trusted servers. They can't even do light validation. So yeah, we're quite ahead in that front.
Cool.
Was there another question? Did you have something? Oh no, Callan.
Whomever. Okay, so yeah, just I mean, so it is a tree, I guess, or a chain. I guess you could say it's a tree, because it doesn't fork, right? So so unlike DAGs, which can fork and then it can merge, it's crazy. But just my question actually was, so let's say I'm Electron Cash, right? And I contact some server that's hard coded in my code, and it gives me this JSON file, and it has like a blob of transactions, and all I care about is I just want the latest icon, right? And I also want to verify that I'm not being lied to. What do I have to do? Do I take each of those transactions, and then in each of them there might be an OP return, and then I look at the URL, and then I download whatever JSON document is there, and merge all the keys I get from each of those subsequently, replacing existing ones, or what's my strategy for just getting the latest icon?
So there's the easy way, and then there's the more higher validating way. And we actually, in the spec, I could share but in the spec, it's near the top. It the first part of the technical specification, it clarifies there's two types of clients. So we call all the implementers of this protocol clients. There are metadata validating clients that actually fully support and acquiring and authenticating chain resolved registries, and many of those will also support checking the identity claims of identities. But also to get started, the day one implementation strategy is you can do a DNS only thing. DNS only clients is how it's described. And that is your wallet would literally fetch from whatever URL is trusted. Like if the user says they want to add the registry from bitjson.com or whatever, then your wallet hits bitjson.com/.well-known is a standard industry prefix. And then there's a standard file location for where the registry must be served from bitjson.com to be considered a registry that is published by bitjson.com. And your wallet would simply grab that JSON file, and from there could start displaying all of the icons, and that could be it.
That would be me not validating, just sort of
yes,
bitjson.com.
Yeah.
Okay.
And then to validate more intensely, you would check what you get in that registry. You would check the auth base there, and you would start to recognize that registry by its auth base rather than its URL. So you can start by downloading from bitjson.com, but from then on, you start using the auth base, so that if bitjson.com goes down or is confiscated or vulnerable, a hacker takes it or whatever, they would have to get the key controlling the identity for that registry, which might be a multi-sig or have a vault situation or something like that. And your wallet could then do this light client validation thing where you trace the identity history for the registry's identity, and then you check that registry publication output. And that registry publication output has a URL, or it has an IPFS content ID. So from there, you can look it up. And it has a hash, so you can validate that what you get is what you're supposed to get. That your question brings up a very good question, though, about kind of the chain of custody of this information, which is a complicated rabbit hole. But basically, and this is how a lot of the cryptocurrency ecosystem has evolved. You'll look around and you'll see all these token systems have like ways of publishing information about the tokens on chain, and they've got fancy, significant amounts of infrastructure and policy around like how do you broadcast on chain your information about your identity. But if you go and look at the wallet ecosystem, no one is using it, because in reality, the biggest issue for a lot of wallets is impersonation of these identities. And it just doesn't matter at all what people claim about their tokens or about their identities on chain. If you know the identity, it can be useful to look up what they claim, like if they signed a software hash or something like that. But if you're just learning about an identity for the first time, giving it a name and a token and a symbol, for example, if it's a token identity, you don't want to trust the chain for that information, because like if you look at SLP registrations, a ton of them are national currencies and there are like 3 or 4 at least different USDCs and tethers that are most certainly not issued by those organizations, et cetera. So many on-chain publication strategies are pretty poor ways of first encountering an identity, or encountering a token identity for that matter. And so if as a wallet, what you really want to care about is, first, you want to have an embedded registry that is trusted by the developers of the wallet. Like if you're building token functionality into your wallet, it's probably a good idea to go ahead and bundle a registry that is kind of the baseline registry. But then also your wallet can also have some other trusted registries that you go ahead and that you trust to update, or that you offer to users. The users can like click the button and it lists all the tokens that are registered by an open source project that might manage the registry on GitHub or something like that. And it might have a multi-sig signer set or something. But the important thing is that when an identity decides to change something about their identity, if they decide to change their name or their icon, you don't want them to change their name or their icon to something that's going to end up defrauding your users. And that's, of course, that's been a big issue on other cryptocurrencies. It also happens on social networks where you see under any popular post, there's like a few famous people with check marks, with blue Twitter verified check marks, and they have the name and image of some famous person, but it's actually a hacked verified account that has had their icon and name changed, and they're being used for an affinity scam, right? So this happens everywhere. Anywhere you have an identity system, you have impersonation issues, and so it's very important from a wallet's perspective. Your concern is that your users don't get defrauded, and it's okay if identity information actually gets updated slower because it passes through some registries. So there's like the verification step is like, as a token issuer, I might publish information about my token using a metadata registry output, and everybody in the world with an indexer can find all of those outputs and put them all in the same directory. They can have even an automated system to open a pull request against a GitHub repo that is like a community managed registry or something, right? We can automate most of that, but you still need someone to check to make sure, or some system to check to make sure that they're not changing their identity from JSON coin to US dollars, right? Yeah, it's like if I have my JSON coin fungible tokens, and right now it's a loyalty token, but I make a little update and push it to the chain, and now it's a gold-backed currency, and all my gold is held by the U.S. government in Fort Knox or whatever, right? That's almost certainly not the case. But if your users of your wallet see the icon and see the name and the description, there's a chance that they may be defrauded, right? So
this is a bit of a trust delegation. I mean,
yes,
you really want to have the decentralized stuff. It's not censorable. It's on chain. Everybody can check it. But then you have all the scams. So you need something, and I'm really happy that I've been drilling you about that. That you came up with a solution that has a second layer, essentially, the registries that can do the curation, censorship. And that can, say, well, you're looking for famous people. Here's the ones that actually are verified as famous people, and they actually link to these guys.
Yeah.
So it's just nice because you can have a market of registries essentially that somehow, hopefully, can make some money or something, while the rest of us can't get censored because it's still an uncensored blockchain. I kind of like that. I'm willing to see how that works out.
Yeah. So the censorship resistant part is the part that the registries themselves get to publish on, and the wallets don't necessarily trust whatever you put on chain as being the data. Instead, they trust the censorship resistant registries, which can be they can be long-term identities that are pseudonymous. They can be registries can be published by pseudonyms that are still well trusted, and that's likely to happen for markets that in countries where certain markets are not legal, in certain countries where they are. Is like there are American companies don't want to do things that, even if they're legal in the US, they don't want to do them if they're illegal in Europe, for example. And there's like weird regulatory issues there. And so it's possible that there are different levels of identities that will want to serve different markets. And one of them, of course, is pseudonymous markets, being able to publish file sharing and things like that are frowned upon. So those are fully, the metadata registry stuff itself is itself censorship resistant, but it does not follow that you get to write whatever you want in the view that users see in their wallets. And John, Emergent Reasons, did you have a further questions? Yeah.
Yes. So this is going off in a different direction. So one of the issues with coming up with wallet design for wallets that are actually intelligent and able to handle all of this kind of thing, right, is state management. And this is more or less, or part of this scheme is how to store state in a way that's verifiable with the identities and so forth. So, but one of the issues there is how do you avoid getting into arbitrary code execution, like into the territory of arbitrary code execution, where you've got this registry of information, and it sounds like it's mostly been resolved by now, like from listening to the conversation. But I just want to ask the question.
Yeah, it's a great question. And the instant answer is we use the BCH virtual machine anywhere where we need arbitrary execution. It's a great solution for wallets. It is specifically designed to work with our system. It is specifically designed to work with types of commitments that end up in tokens. It's already available in most of the wallets, many of the wallets that do any significant amount of validation, or pruned nodes and things like that. And it is designed to be minimal, easy to implement. It has a very clear standard. It has an on-chain way of knowing what standard is currently active. There are just dozens of properties of the Bitcoin Cash virtual machine that make it the ideal execution environment for doing generalized execution if you need to do that in wallets. One of which being you can download a metadata registry. So I'll give you, so in the metadata registries, there is an example of what you could call arbitrary execution. The way that NFT commitments get parsed is actually using bytecode, virtual machine bytecode for the Bitcoin Cash virtual machine. And it's literally, we push the way that the spec works, you push the commitment contents, it's up to 40 bytes that are inside the NFT. And then the parsing bytecode operates on that commitment. So it can split it at byte 8, reverse it, cut that, do some binary math, whatever. But eventually it needs to push a set of elements to the alt stack as a set of returned elements that can be labeled by the spec. And what's cool about that is we know for a fact that the resource requirements are very limited. You can't possibly write a script that's write a parsing script for this thing that is abusive, like where it loops infinitely, or breaks out of its execution environment, right? So it's everything is encapsulated using the Bitcoin Cash virtual machine. And if you dig through it a little bit, in order to be able to represent the fields that are inside of NFTs, you need some sort of arbitrary execution, because you need contracts can put anything in NFTs. Like they can put a number followed by a concatenation of followed by the OR of a bunch of followed by a bit field that has a binary digit for a number of Boolean properties, and then after that there might be a string, right? And that string might be something that's coordinated across several contract or something. There's a lot of possibilities of what contracts can do. But what we can be absolutely sure of is that if you can define your parsing function in the contract language, that your parsing function will be able to parse it. So it's just the ideal virtual machine to write parsing functions for things that are outputs of the virtual machine is the virtual machine.
Right.
And I would say that is the correct answer in a lot of cases for wallets, where wallets need to deal with arbitrary execution. You have two options. You can try to standardize the heck out of some sort of parsing strategy. So an alternative in another universe, we could have a commitment parsing strategy that is defined using regular expressions. But regular expressions are consistent across languages, and that's going to be hell. So like, I mean, there were like a number of smiles I could see on the screen as soon as I mentioned it. But I kid you not, there are cryptocurrencies that do it. There are other, to speak very specifically for wallets, there are other cryptocurrencies that have, partially signed transaction formats. Yeah, we could call it partially signed Bitcoin Cash transactions. But these are very, very kind of rigidly defined standard specifications that are not quite, they're not quite arbitrary execution, but you have to do so much implementing that it might as well be.
Yes,
And it's actually limited because it's not arbitrary execution. And it's like, a much simpler solution would be to use some sort of arbitrary execution environment that you can trust. Your options are WebAssembly, basically, and there are a few others. There used to be something called Moxie-Box, but the Bitcoin Cash virtual machine is actually really fantastic for parsing commitments in this case. And I think also for wallets in general, I would say it's also a useful execution environment for being able to assemble unlocking bytecode for transactions, for signing arbitrary outputs of weird types of contracts. And that's actually how BitAuth IDE works. If you've seen ide.bitauth.com, under the covers, the way it signs transactions, the thing that does the signing actually gives you access to a arbitrary execution environment, but it's inside the BCH virtual machine. So it can't be malicious. You can run a template from an untrusted entity, and it won't crash your wallet and it can't steal anything, and etc.
Right. Okay. So you're as safe as BCH is itself. Okay.
Right. And of course, the
cool
BCH VM implementations are already in an adversarial environment. So we can actually be a lot more confident about them even than some WebAssembly implementations these days. Like WebAssembly is relatively new. And if you're using a new engine, it's probably not as secure as the Bitcoin Cash VM. It doesn't have a bounty associated with its cracking. Right.
Yeah, I mean, all those like WebAssembly, they're Turing complete. I mean, you would just not use those because they're going to, they could loop forever. The halting problem. So,
yeah.
Exactly.
Ethereum solves with the gas thing.
Right. Yeah. So
you definitely want something like a fourth like language, which is not Turing complete.
Yeah. Or in this case, what matters is just that we have a definitive limit for when it has to stop. So, and the Bitcoin Cash VM has definitive limits, and we can just use the same limits. You can do most of what you need to do in that space.
That's a great answer. Thank you.
That's a great question. So thank you for bringing it up, because I did want to mention that about the commitments. It's an interesting thing that when you look at the spec, you'd be like, what? But if you try to think about the problem for any significant amount of time, you will, I think, come to the same conclusion that the correct VM to parse the outputs of the Bitcoin Cash VM is the Bitcoin Cash VM.
Nice. Thank you.
Callan, did you have a question?
I did, yeah. I don't want to monopolize it. Just keep thinking of questions. But if other people have them, preempt me. But so I'm having possibly because it's the first time I've actually looked at the spec. I know you published it a couple of days ago, and I apologize if this is a stupid question. So you have these OP returns that have as a payload a URL, right?
Yep.
But the ultimate thing that a wallet cares about is basically conceptually a set of key value pairs that are well defined, they're well structured, right? How do you get like that URL? Is that just to a JSON document, or is it, or what is going on as far as the URLs that are in the chain of custody, and then how does that map to like the final end product the wallet cares about, which is a JSON document?
I'm going to scroll down to that section, and I'll go ahead and share my screen. So
a good question or not, I don't know.
Yeah, there are two types of publication outputs. There are IPFS publication outputs and HTTPS publication outputs. The structure there is every single one of them will have a hash. They will always have a hash. If it's IPFS, it needs nothing but the hash. If you are publishing with HTTPS, and we provide both options because you do need some flexibility. In many cases, IPFS will be the correct choice to use. But there are some cases where HTTPS is important, and in those cases, in the op return, you have the hash of the document itself. When you download it from whatever location, it should match that hash. With IPFS, you're actually looking it up by that hash, so we don't need another URL. But if you're using the thing that differentiates in the HTTPS publication output is it has one more pushed element, and that's the URL.
Right. So you get right. Gotcha. So you get those documents, and you just take the latest version, or do you sort of merge them all?
You get those latest documents, and you take the latest version of the identity from that document. And there's more description in the spec for what to do with that stuff. In the identity, here I'll show you. In the identity snapshots bit, at any moment in time, only one snapshot is considered current for an identity. However, it's possible to have there's a time.complete function on the snapshots that can indicate that an identity is in the process of a migration. And so it's kind of it's a very high level kind of API to describe some things that can happen in decentralized applications. But it's possible for decentralized applications to have like a migration period over which currently the category ID is this for the token, and after the migration it will be this. And there are actually covenants that support both right now, and there's like a migration so that there are a number of ways that you can build pretty complex systems that require a concept of there being a migration in progress. But in general, when you look at that document, you'll look at the JSON document. There's an identities field, and you'll look inside the identities field, and you'll look at the auth base, and then the snapshot at index 0 is the one you're going to use. If you're displaying more information in your wallet, if you want to display like a timeline, you would maybe use the other snapshots. But by and large, you just look at identities, auth base, index 0, and that's your key value store of what the stuff you need.
Okay. I think I got it. That answers my question. Thank you.
Yeah. There were some questions. I don't remember which one went up first. Was there a question related to that? What we were just talking about?
Yes.
Yeah.
I was asked because I had a previous question along the same lines, but I thought it was answered. It seemed like the registries. I was going to ask like the relationship between a registry and the identities, the auth bases that are in.
Yes. Yeah, it's a great question. So registries. Most registries should have an identity. If you look through the spec, we make the spec very easy to get started. There is a strategy to publish a registry without doing any on-chain transaction stuff, and there's a strategy to fetch from the registry without doing any on-chain transaction stuff. So I'll say that as I'll prefix all of my response to your question there. It is possible to do all of this without any on-chain magic, right? The moment you want to start verifying better, where you want to prevent targeted attacks and ensure that vulnerabilities at the DNS level, basically, where a website gets hacked or something like that, where you want to secure against that stuff, the way the spec is designed, there is kind of a minimum viable usage of this stuff, and then you can add the identity stuff to that. And when you do that, a registry should have an identity. And when a registry upgrades itself to be more than just a website, if a registry isn't just hosted at a website, it should have an identity that is tracked on chain. And then from that moment on, any clients that are using that registry should check its broadcasted outputs. Check them, do the proper validation to make sure that they're not hitting a targeted attack. So it is possible, and we can expect there are going to be a lot of clients out there, a lot of wallets out there in the very long term that will never support this identity stuff. It's perfectly possible that there are, because they might be like indexers, basically. They're like websites that they're like, for example, like a block explorer doesn't many of them, if it's kind of a self-hosted thing or something like that, it may be too much work basically to add the code to do this stuff. And all your Block Explorer really needs to do is fetch from somewhere to get some icons and some names. And no one is going to lose any money if it shows the wrong icon or name or something in this particular application. And so that application may not end up implementing all of this other stuff. But in general, wallets, it's going to be a very good idea to implement the full security stuff. So yeah, I'll say to get started, you can publish a registry as just a website, and it will work. And wallets should probably push users to use registries that use proper authentication that can't be targeted attacks. Yeah.
I guess so. The kind of like rephrase when I was asking about the relationship between the two like there's a registry as an identity, like not a. I gotta be careful with my words. So there's a registry as a
as an identity,
right?
Yeah. A registry can have an
identity.
One-to-one relationship between a registry and identity. It's possible for a registry to not have an identity yet because they've not done any on-chain stuff. But when they do get an identity, that's when we get all of the when they create their identity and they put it in the registry and they mark themselves in there.
So just to clarify, so there's two kind of like entities. I'm using the word entity just to be a little general. So there's the registry who's operating a registry. So there's multiple of those that are out there, and then there's token holders. Since this is a proposal mostly about, I guess, tokens and how to go ahead and interact with wallets. Then there's the token creators, not the holders. Token creators.
Issuers.
And so the issuers would be going ahead and I'm assuming that the issuers aren't the ones putting the op return into onto on chain. It's the registries that are putting up the op return, or both are possible, or are both entities going to be posting on the blockchain with that op return to be safe? The registries, if they are doing the identity stuff, if they're validating properly, then the registries will put an op return on the chain with their registry and the hash of the their full copy of everything. And that includes everybody else's data. And the registries are the one who are accumulating that data. As an aside, token issuers can also have an identity as a token issuer, and the token itself. So the token itself can have an identity, and they can also have a registry that they publish for that identity. Wallets should not look at that identity for the metadata for that token, because it could be impersonating something. You don't actually trust anything you just find on chain. You should trust a metadata registry. You should trust one that a registry you trust. Ideally, in general, most wallets are not going to want to trust a token to talk about itself. They're going to want to trust some other trusted registry to talk about lots of tokens. But those registries may be updated by looking at the chain and seeing what the tokens claim about themselves. Like that's a good way to get that information into all of those registries is for token issuers to publish what they think their entry should say. Yeah,
and
so that makes a lot of sense. I was thinking the same exact thing. That would make sense that the token holders would publish this with their auth base.
At the latest transaction in the chain.
Exactly. Using an identity.
That's exactly right. Yeah. So the critical piece is that the registries themselves, like the thing that actually matters to wallets, is looking up what the registry says is the hash, and that's all. That's the only thing wallet will need.
But if the
registries, like the publishers of registries, might do on-chain scanning to like do automatic updates and have like a human verifying it or something. And that's not part of this spec, but in general, it's probably a good idea for token issuers to publish a registry they consider to be canonical for their token. Like, here's the description we want everybody to use. Here's the token icon we want everybody to use. Here's our commitment API. Like, here's how you could break apart the commitments to tell, like, here's where the image is and here's the location of the asset or whatever. Yeah.
Gotcha.
Was there another, John, did you have another question? Emerging reasons, sorry.
Got a list. Yeah, actually, I have a really important question, I think. This is in line with the same idea, right, of being your own worst critic for something that, if we assume success, this is a big deal. So how does this play out in the long tail of scaling? Because if I take it to the extreme, what we're talking about is basically a UUID for everything. right? Like a new IP
Oh, funny.
system
Yeah.
almost, right? So how does it play out in that long scaling tail?
Yeah, that's a good question. I would say the scaling requirements of this system are equivalent to the ones for Bitcoin Cash in general, because the UUID the globally unique identifier we're talking about, is transaction IDs. Every identifier is a transaction ID. So if Bitcoin Cash can scale to billions of transactions, it can scale to billions of IDs, right?
Yeah.
And the system itself, importantly, does not do anything with indexing, like address, like it doesn't look up, hey, are there broadcasts to this address? Because that becomes a scaling issue, because you have to be scanning the chain, you have to be scanning every single transaction that comes through in order to see if it's one that matches here.
Yeah.
On the contrary, this system is really nice scaling wise. It actually doesn't touch, like, from the chain's perspective, this system is like basically invisible. People are going to be creating transactions to do things with their identities, but they're not going to look much different than normal transactions.
Right.
They'll have some op returns and stuff. But in general, the system doesn't become more expensive as there get to be more transactions. These auth chains, we can actually put all of the transactions in a chain into a single document and share it from an untrusted location, and it can be verified by light wallets in the same way they verify normal transactions, checking the current UTXO set. So in all of those ways, it is exactly the same scaling requirements and impact as just having more transactions on chain.
Right. I was imagining the worst case is like 2. You have an identity that makes a single transaction, so it's like O of 1 anyway for kind of space and computation. So, but even then, taking it a little bit further, if you do think about all the things that can possibly be engaged in commerce, right? Especially as machine learning starts to really pick up, and the possibility of independent entities and just a large number of people and all kinds of things being involved in commerce, right? Once things become trustless, that actually becomes possible where it's not today.
Yeah.
So in that world, and we've discussed, or you have discussed with cash tokens, side chains. Would it be possible to integrate this whole idea with side chains so that if I wanted to do a huge number of identities with my own, or using the same type of schema, but just doing it somewhere else, is that something that would fit in pretty easily to do things on side chains?
Certainly. I would be very surprised to see that happen as a scaling solution on the main chain. Like, if Bitcoin Cash can't handle more transactions, then that's like an issue with Bitcoin Cash as money. And so these are simply Bitcoin Cash transactions. So it's actually just throughput that would be on the main chain. But I definitely expect to see these identities on side chains when they need to be used on those side chains. So if there are side chains that are basically copies of the Bitcoin Cash system that also add a bunch of other stuff. So a very good example is a prediction market side chain that forks from Bitcoin Cash on some day or whatever, and adds as primitives to the chain, as primitives to the consensus chain, the concept of markets with logarithmic market scoring rule kind of built in and stuff. Like, there's a lot of stuff that we definitely wouldn't want to add to the chain in Bitcoin Cash, and also would be extremely expensive to implement in the Bitcoin Cash VM. So implementing it in a covenant or in contracts is going to be a lot slower and more expensive, just from a technical perspective, than to build a side chain that has a trustless peg. And so that side chain may very well it'll use Bitcoin Cash wallets, of course, because it would be a fork of Bitcoin Cash that does all the same stuff. And it would be, it would have Bitcoin Cash as its currency. People would move Bitcoin Cash onto the side chain and move it back over a decentralized bridge. And it would likely be supported by the same wallets that support Bitcoin Cash. That would allow them to hold, the side chain to Bitcoin Cash and allow them to participate in these markets. And in that case, I can see that there's a good chance that if you had side chained Bitcoin Cash on this thing, it would be super inconvenient to have to like send it back over and then you do identity stuff on the other chain if all you're doing is all in this ecosystem. So I can definitely see it being used in side chains, but I would say like in general, this is a great use case for main chain, just because like the data availability is going to be better. You're going to have better connectivity for light clients. It's super lightweight anyways. Like we're only talking about a couple kilobytes for these light clients to talk around this stuff. Even if there are a billion people making identity updates once a week or once a month, that's still way less than their actual commercial transactions, right? If we want to have a billion people be able to use Bitcoin Cash as cash, then identity updates are still going to be a very small fraction of that, even if they're all doing it on main chain. So
okay, thanks. Just wanted to
question.
Appreciate that.
Was there another? Saeed, did you?
I didn't have a question, but I just wanted to make a comment because based off of like the same conversation we were having just a second ago before emergence, the metadata registry publication outputs, how it pushes out a hash and a HTTPS URL, and how both the token issuer and the registry can go both publish these publication outputs. Those publication outputs actually remind me of almost like DNS links in the IPFS kind of terminology, because it has a hash there, and so a hash it's like notifying the world of a new hash. And so it kind of be related like to IPNS, interplanetary naming system, and this similar. I'm just saying that this looks like an alternative to that specific part. Looks like an alternative to IPNS using the Bitcoin Cash blockchain, kind of like
exactly. And that's a good point. And one way to think about it is a lot of this identity stuff is strictly an alternative to the domain name system, to DNS.
Exactly.
And could be significantly better than using DNS because in a way DNS treats identity as kind of a secondary thing. DNS SEC, the DNS security extensions is a relatively new thing. It's still not even universally supported. So the DNS approaches the whole process of identifying, key value bits of information with identities. It approaches that from a technical perspective that was in a very non-adversarial internet. And we turn around and approach it from the other direction, where everything is super adversarial and it's all very strongly identified. And actually, we have a global broadcasting system, the transaction system, which can support real-time updates. So you don't need to have time to live values for records. You can actually update your record, and light clients can actually hear the broadcast and update it immediately. So that's actually mentioned in the spec, that actually a benefit of upgrading your registry from being a DNS only registry to also working with proper on-chain identities is that light clients can get updates instantaneously. That you can get real-time updates. They get notifications when there's a unconfirmed output. You can get a notification when there's an unconfirmed transaction for an identity. And as Tom was mentioning, it's you keep track of these identities the same way you keep track of normal outputs in your wallet. So you can track it. If you can track an output is being spent, you can track if an identity is being updated. So it's a great observation. This is definitely approaching the same problem that DNS attempts to solve, and we attempt to solve it in a much more secure, verifiable strategy.
So what I'm thinking is that with IPNS, you already have an HTTP gateway. Most people are going to connect to IPNS or IPFS through some kind of HTTP gateway. And so a gateway is already basically listing a bunch of hashes already, and that's essentially what the registry is also doing, is keeping a list of identities, which would be transaction IDs and ultimately auth bases. And so there's a technique I already use with flipstarter.me, and basically I go ahead and put my gateway goes ahead and filters all the hashes that don't match my specific schema, so that I can go ahead and so I can verify everything basically. And so I see that almost like a similar, and it's capable of doing censorship. In the same way that a registry, I'm just saying that I see the role that a registry is playing is very similar to an IPFS gateway, and it's using BCH as the layer beneath the kind of like the consensus and security. So yeah, I think this. Yeah, I just think this is probably some avenue there to kind of like tweak how the so I can both integrate with BCH and with the IPFS system, kind of like seamlessly. And I think also with the HTTPS URL that's already in the publication output, it could also, that could be a little bit of the adversarial part. You can, because there's already tying in between of like the real world kind of identity, like getting your information from like social media or something like that, or not your information, but get an identity to kind of point it back to the Bitcoin blockchain, especially if something gets stolen, right? And so you can kind of tie the two together, since both sides could also be pointing to the same info. So if the DNS doesn't match, if the DNS is not pointing to the same thing that the Bitcoin blockchain is, the bit auth identity is pointing to, then that could be a sign that something's wrong. Like either the account got hacked or the blockchain got hacked. So I can see them actually playing a complementary role with each other, doing it this way.
Yeah, it'd be great. And I saw you mention that, if you wouldn't mind opening up an issue on the repo, and we could talk more about IPFS.
Oh yeah, it's issue number 1.
And stuff like that. It'd be great to, maybe we'll move that discussion to long form text. Awesome. Tom, did you have a question or a comment? Oh, you're muted. There you go.
Yes. Yes, I was thinking about this a bit longer and trying to figure out, how does this work? How does this interact with other stuff? And so the first thing I was thinking about is that you basically could just integrate this with a payment protocol. So if you look at the most advanced payment protocol, there is the BIP70. It relies on X509 certificates, which are really not easy to do in any sort of way. And you could just replace that with a simple hash and maybe even a full dump of the history, and the client can verify that. Which led me to the second thing, like, okay, but anybody can say that they're them. Oh, but maybe since we are actually requiring you to use the normal transaction format and spending a transaction to make a new update, you're probably going to use the standard way of having private and public keys. And so you can also sign a message with the current identity, as it were. And an identity is then your current not yet spent transaction output. The off head, as you called it. And that means that you can also just sign that whole thing with the current system and with the current key, and say, hey, my payment protocol asks for a payment of this, and I can prove I'm them. So that's kind of cool to a combination. And I made a next step and then thought, oh wait, then maybe what you want to do is make a suggestion that when people make such an authentication chain, they use an HD wallet. In other words, every single time that you update your tip of your authentication, it uses a new private key. So what that means is that if I see that somebody might have been hacking my identity, I can just move to a new public key, and then any old systems can no longer be used. The older public key can no longer be used to say, hey, I'm me. So that's kind of cool.
And I'll say this is actually not in the chip itself, but I may very well add it. But the primitive itself, the goal for the primitive itself is that the 0th output is called the identity output, and that is what controls the identity. But at each step, the second output, the output at index 1, we could call the signing output, and you could create transactions without output as a way of signing an arbitrary message that is not necessarily on chain. So if you want to have off chain, just straightforward message signing that uses these identities and can do things like multi-sig signatures. So like something you can't do if you just publish a public key is have an off-chain multi-sig signature with a set of 7 of 8 signers or something. But you can definitely do that if you standardize that the signing output can be spent in an invalid transaction that is invalidated in a very specific way, so that it's not actually valid on chain, but still proves that the holder of the signing output signed that message. And then, of course, the way to revoke the key is to move the identity forward. And so it's actually quite cool. You can build a trusted setup where I'd give an example of like Bitcoin Cash node could have a release team that has 4 or 5 signers or something, and you sign in this case you'd want to do that as an on-chain broadcast. You would put the hash of the release in an op return output that everyone can see, and you'd go ahead and put it in the latest identity output, in the latest auth head. You would put it in the like output 1 of the auth head, whatever, and then anybody in the world would be able to see that the latest identity there is has that signature. I'm sorry, the latest release is that hash. You could also put that output at like output number 2 and keep that signing output, keep index 1 for off-chain signatures that are not transactions that are broadcastable on chain, but they're encoded as transaction, and they use the Bitcoin Cash VM to do the authentication strategy. So I can get that transaction and run it through the BCH VM and see that, hey, this group of people signed how they expected to sign for some arbitrary message, and it can be whatever.
That sounds like an interesting approach to a lot of more complicated solutions. What about the very simple solution of, hey, I want to log into a website, and most of the transactions basically end up having a public key or a public key hash as what you pay to. You could reuse that to simply authenticate to a website. And it has nothing to do with a transaction because it's just standard public key cryptography. Yeah,
it'd be awesome to start working on some standards like that. That would be exactly how we'd want to use these identities for authenticating the websites. If you're interested, if you want to open an issue on the repo, we should talk about it there.
Sure.
We should. It would be great to start building out other. That'll probably be a different spec, but it would be awesome to get that rolling in the Bitcoin Cash space.
At least have it as a note of, hey, we want to make sure we keep this in check when we do the main one. Yeah,
keep it possible to do. Yeah, totally. Sweet.
Thanks.
Emergent, did you have another comment or question?
Oh yeah. Hey, I'm gonna have to go, but
Yeah.
before I go, I had a serious question. So far you've replaced PGP, DNS. Are there any other 3-letter acronyms, like ancient acronyms, that you're planning to destroy here, or is it just those 2, or
just those so far?
Just those 2?
The www.
No.
www.
No. Yeah, it is. I mean, it is true though that within the Bitcoin Cash ecosystem, these things will be a lot easier for Bitcoin Cash wallets to rely on than, for example, DNS. Like, surprisingly, and I think we talked about this earlier, but like, for example, one of the reasons that DNS TXT records are not used as part of how this standard works is specifically because that would exclude a lot of browser applications. They would not be able to interact with these metadata registries if we had to use TXT records to broadcast stuff. So instead, we use the well-known URI standard, which works really well and also works in the browser. But there are places where clients that are important to us in the Bitcoin Cash ecosystem are not able to use, in that case, DNS. They're not able to. They don't have access to DNS. They kind of do, but only indirectly. Or in the case of PGP, of course, like we can kind of roughly use PGP, but in general, PGP signatures don't do much for you in terms of, you have to trust a lot of things about an identity to believe that the signature from their PGP key is worth anything. And then revocation is its own mess. And it's funny, actually, if you look on key registries and stuff, you look at the number of PGP keys that have had their certification, their revocation expiration date extended. It's like everybody just extends their keys and extend.
Oh yeah.
And so now you have a state of the world split, where some clients will think that this PGP key is expired, and some will think it is not. So there's all sorts of messes inherent in this, and it ultimately comes down to the double spending problem. Like the blockchain is made to solve for that problem. Yeah, there are a lot of places where both DNS and PGP, and there's probably a few others that where using this is significantly easier for wallet clients and for us in the BCH ecosystem than to try to use things that you might otherwise think are like, oh, that's a more standard thing. You should use the more global standard thing. But in these cases, the global standard thing is, might be trash for our use cases.
Right. Okay.
Yeah.
Well, very nice.
Thank you.
I'm gonna have to go, but
I'm gonna go ahead and wrap up the recording now
awesome.
too, because I thank you very much for everyone who's been on, and of course, feel free to hang around. Thank you, everyone who's listening to the recording now. I'll try to get this on the interwebs as soon as possible, and I will go ahead and end it here. Thank you.
Thanks, Jason.
Thank
Take
you.
care,
Thanks,
everybody.
Jason.
See you.
Thank you. Take
Appreciate
care.
it.